systems. The last component to discuss, and is actually of great concern to the regulatory agencies, is how the backup system works. So when our rainwater system runs out of water, and we need to continue flushing toilets, we need to have another supply of water, typically from whatever else is going on in the building. These backups are only going to be on the non-potable systems. At least all of the potable systems that I've designed have been sole source, which means there is no backup. So I size them to meet the 100% of the demand. But however, the non-potable systems typically need a backup. You can either direct plumb your potable water into the system so that when the cistern runs out of water, pump kicks off, solenoid valve opens up, and your potable water from your building just flows through the non-potable pipes to the fixtures using that pressure of the potable system. When you do those systems, you need to put a RP device. That is a backflow prevention device. And DCVA means double check valve assembly, or reduced pressure principle backflow prevention device of the type that's on the right there, in there, and that provides separation of the non-potable system from the potable system. Because if we didn't have that in there and you had a fire down the street, fire department hooks up to the hydrant and they start pumping water, you could actually have a siphon system where you siphon water out of your non-potable system, contaminate the potable drinking water system. So this is of paramount concern to the regulatory agencies, so that device needs to be there. The other way to prevent that back siphoning from happening is have an air gap. So you simply use the potable system to top off your cistern, and then everything happens as normal, and there's a gap of air between the water surface and then you cannot get a back siphon. And now we're going to kind of talk about the governing codes. Within the Uniform Plumbing Code, which governs all the piping of water inside and outside a building, enforced by the Health and Building Department, there are certain key chapters that apply to rainwater. This is going to be a pretty high-level review of some of the key requirements. There is now Chapter 17. Didn't used to be applied in Washington State. We used to have to deal with that, but now there is. And there's Appendix K, which deals with potable systems. And so this is a huge help for our designers and help us getting our permits, because there's an actual rational basis for designs. The WAC reference at the bottom is the Washington State amendments to the plumbing code, which you should check out. And health and safety issue number 1 is the cross-connection issue. That is the chief concern of an agency when you go to get your permit. And so it's located on the backup line. It's necessary to protect the potable supply in the event of a siphon situation like I described. RP devices are common. They're often required at any large commercial water connection. They are common for certain commercial uses, just have to have a premises isolation. They'll be indoors, they'll be outdoors in a box. So they're common. The issue with a backflow prevention device has to be inspected typically once a year by a private entity that comes and inspects. And so there is a cost to doing it that way, and that's often cited as a reason not to do it, is because we don't want to incur this annual fee. I still think it's better than dual plumbing your rainwater, but again, that's designer's choice on that one. They both address the requirement in different ways. There's a WAC there for you and an EPA manual reference if you want to do a deep dive on cross-connection, and then local codes vary on this issue. There's different preferences of local health departments and plumbing officials on what way to go. So I think I mentioned the air gap. This cistern we're looking at happens to be King Street Center down in King County's building down by Amtrak station in SoDo. I think it was the first commercial rainwater capture system in our area, late 90s. Photos of a variety of backflow prevention devices, what they physically look like. There's the double check valve assembly to the left, but the one in the upper right is where you're going to wind up typically. The RP device is what is typically required. And then just to understand what a typical commercial scale premises isolation, which is usually required on any commercial water service greater than a certain diameter in most jurisdictions, is required to have a big double check assembly like you see down there on the bottom. Pipe labeling. There was a wide variety of practice, and there remains a wide variety of practice, though there's less variety in the practice now because there's been some additional regulatory guidance that's been published, which is really starting to standardize the industry, which is a really good thing, because this used to be the Wild West about, it was just local officials would require all different types of labeling, pipe colors. There's an ASME standard 13.1 which talks about pipe labeling, but the requirement now, or the recommendation, is it's black lettering on a yellow background, 4 feet on center, saying non-potable water. That is my recommendation, and that is what is, I believe, the emerging practice. However, purple pipe typically is required for reclaimed water. So this is an issue that ties back to what I talked about in the beginning about how there's a conflation of reclaimed water. But I mean, purple pipe really is any non-potable water, but I think more typically associated with reclaim. But for the purposes of our discussion today, I think both are equivalent, and both would be allowed by jurisdictions, I believe, depending, or one or the other is going to be required. Black lettering on a yellow background, 4 feet on center, or purple pipe. So the one in the middle there is the distribution at a project of mine in Bellingham, which is rainwater ready, and in that case, we went with purple pipe. So the pipes are labeled. The fixtures are also labeled. What the recommendation is, and I'm giving you a wide variety of how this can look. The figure in the middle is the symbol for non-potable water, and that is what is in the plumbing code. My recommendation is that that is what is used above a plumbing fixture. While I have not heard of it being a major problem of people drinking out of toilets, however, each fixture does need to be labeled for non-potable in the event that somebody is very thirsty. But you can see on the left, it was as simple as using a lettering machine that just says rainwater collection non-potable, and that was acceptable. I don't think that that's ideal. And then on the one on the right, which is actually from a project of mine down in Vancouver, Washington, it was actually integrated into the building signage in a really stylistic way, which I think is really nice. So I think you can look at it each way. What the code says and what I'm recommending is basically that you have that symbol and you have the words caution non-potable water, do not drink. At each fixture, hose bib, anywhere the water is coming at the people, you want to have that written. Also, equipment rooms need to be labeled as well. You need to have a label on the equipment room. So if you've got rainwater equipment with non-potable water in a plumbing room, in a meter room, in a riser room, in a fire room, wherever you've got this equipment, on the door, you have this sign and a note that says that there is non-potable water in there, so that a plumber showing up to do work on the building, to run a new branch line off, to feed a new restroom, doesn't inadvertently connect into the rainwater system, which does work. There's an unnamed large public project that happened in the Pacific Northwest in the last 5 years where there was a cross connection after extremely diligent review. And it happened on the day that the director of the health department was coming to tour the building. There was a cross-connection issue with them getting their cup of coffee. This is a really important issue because it's key to the health and safety of people in the building and requires diligent attention. There's also a need to provide building signs. This is a project that was done for the Port of Bellingham where the cistern unfortunately didn't make the value engineering process. However, we plumbed the building to be rainwater ready. So the rendering you're seeing is actually the building with the cistern. The building currently doesn't have the cistern. So we did the full complement of signage and pipe labeling and dual plumbing so that the building is ready when the owner decides to put the cistern on. It should be relatively plug and play, but that there's signs required at the building entrance as well. There's also labeling required on the cistern. Cisterns are confined space. And so we need to be putting signs on the tanks that say that they're a confined space, just like any confined space, and that indicating that there's non-potable rainwater in the tank, so that everybody is on notice of what's going on and there's not an inadvertent issue. The plumbing code is many, many pages long on rainwater, and you can read it, and there's a lot of other detail in there. But the pipe labeling, fixture labeling, cross-connection control, and the basic levels of filtration that I talk is going to get you 95% of the way there. And then the rest of it, you can study it and see there's a lot of other nuance and detail in there. Some of the other codes and permitting that apply to rainwater harvesting, there is a very infrequently used NSF standard called P151, which applies to potable rainwater roofing and collection system components. So NSF has a standard that will certify a roof material as being suitable for potable use. However, there are no roof materials that meet the standard. There are membrane roofs. They used to have their P51 certification, but they let it go because in places where potable rainwater is done frequently at kind of a large commercial scale, like Bermuda, Virgin Islands, they don't require P151. They just say, what do you got, a roof membrane? Great, off you go. In speaking with the vendors of the roof materials, they're like, we'll get the certification for we'll reactivate it as soon as there's a market, but there isn't. There is one product out there, which is a coating, which can be painted onto a roof that does have P151. If you read Plumbing Code Appendix K, Section 103.1, it'll tell you that if you're doing a potable rainwater system, all your components in your system shall meet P151, or you got to either meet a drinking water component or you got to be P151 for everything that touches the water. And what you'll find pretty quickly is you got one choice. You got to paint everything with one paint. So typically on residential systems, this P151 requirement has not been applicable. In my systems, we absolutely test the water rigorously and have for years found nothing of concern. This is not something that can practically be a requirement because the market has not supported the development of the products. There are plenty of roofing manufacturers who have presented me data of their water quality runoff that shows that it meets the standard, but they don't have the certification because it costs them a lot of money to maintain that certification. Water rights. The water law of Washington State dates back over 100 years, and it controls the use of water in our state from agricultural and domestic and tribal and other uses of water are all controlled and kind of adjudicated through that water law. The jurisdiction of that law, in my best understanding, was all water that flowed horizontally was considered a water of the state of Washington, and before you used a water of the state of Washington, you need to have a water right. So wells that are exempt wells that you drill up to 5,000 gallons a day, exempt wells, you end up getting a de facto water right for that. But there was no de facto water right available for any meaningful amount of rainwater capture. There was an allowance for what was called a de minimis use, which was typically interpreted to be a 50-gallon barrel at the end of your downspout, but anything more significant than that was before August 9th, 2009, was considered subject to a water right and was the reason for denial of 95% of rainwater capture systems of any size because there was not a water right available. However, on August 9th, 2009, the Department of Ecology, through the policy recommended here, reinterpreted rainwater as a quote-unquote diffuse source, and as a diffuse source was not subject to the Washington State water law. And so that policy 107 there you see essentially said that rainwater use is allowed with certain provisions. And the key provisions are that the water needs to be collected off of a roof. There's mention in there for livestock watering via a system that can be placed out that collects water off of a roof structure and makes it available for livestock watering. That's covered under here as well. There is a provision in this, though, that your use of water can be challenged by a downstream senior water right holder who may say that your collection of rainwater is infringing on their right. So this does not give an absolute right, but it essentially opens the door to use the water pending any challenge of that sort. Certainly the scale of capture, I think, would affect that. And so upon this passing, this was the key door that opened that allowed so many rainwater systems to be used for sole source for building purposes. That's a very, very significant regulatory issue that changed a few years ago. 2013, this is a very dynamic field. The ARCSA, which is the American Rainwater Catchment Systems Association, and American Society of Plumbing Engineers and the ANSI got together and published Standard 63, 2013 for rainwater capture systems, which lays out a whole set of recommended design practices which get at the recommended uses that were asked, and we'll go through that. So it's a very robust document, and really it's just a year and a half or so old, and really goes a long way to standardize this practice. And so for any of you that are serious about doing this work, get a copy of ARCSA 63.